This presentation is about technology, research and development, and efficiency. Why would a firm invest in a new technology? The obvious answer? To earn greater profits. Let's do some analysis. But first, some economies, the language of the economist. Let's distinguish between the terms invention and innovation. We'll define invention as the conception of a new product or process, along with the proof that it will work. Innovation, on the other hand, is the first application of the invention to commercial use. A third term, diffusion, is defined as the spread of an innovation to other products or processes through imitation or copying. We can divide innovation into two categories: product innovation and process innovation. Product innovation is the introduction of a brand new product, or a significant improvement on an existing product. And process innovation refers to an increase in the economy and/or the efficiency of a production process. Let's investigate these concepts a little more closely. And while doing so, we'll keep in mind the formula for calculating profits: total revenue minus total cost. Product innovation would change the product significantly. An improved product might increase the interest and the demand for the product, causing sales and thus total revenue to go up. If the innovation is a new product, there will be no good substitutes, thus the firm essentially becomes a monopolist, at least for a while. With the pricing power of a monopolist, total revenue would go up. Apple's iPhone was a significant improvement over the BlackBerry flip phone. For a while, Apple had a monopoly on the production and sale of smartphones. If the innovation is a significant improvement in an existing product, the quality of the available substitutes will diminish, thus making the demand for the product more inelastic. A less elastic demand would also increase the firm's pricing power, and total revenue would rise as a result. If total revenue rises, ceteris paribus, profits will also rise. If the innovation increases the economy of a production process, more output can be produced with the same amount of input. If the amount of output produced goes up ceteris paribus, sales will increase and so therefore, will profits. Or, if the innovation increases the efficiency of the production process, fewer resources will be required to produce the same output. Fewer resources mean lower production costs. When production costs go down ceteris paribus, profits go up. What were the most important industrial technological innovations in history? There is no absolute consensus among economists on this issue, but here is a list that most economists will probably agree with, for the most part. Although there were many important inventions that changed world history that will not be on this list, such as the printing press, the compass, and penicillin, keep in mind that we are focusing here on industrial inventions and innovations. We can go ahead and get these out of the way. They are the earliest, most basic and important building blocks of technological progress in industry that virtually everyone will agree with. Homo erectus started using fire about 2 million years ago, even before Homo sapiens arrived on the scene. The bow and arrow, which dramatically increased the productivity of hunting expeditions, was invented about 50,000 years ago. The domestication of animals, which relieved nomadic tribes of humans from having to follow the migration of the herds, and allowed for the emergence of towns and villages, and, ultimately, society, was invented about 10,000 BCE. Now that people could settle in one place, they had an opportunity to invent agriculture, about 7500 BCE, which dramatically increased the food supply and increased life expectancy and rates of survival. And of course, the wheel, which improved transportation and allowed for longer distance trade, as well as many other applications, was invented about 3500 BCE. The water wheel, which was invented around 300 BCE, allowed for moving water to be converted into mechanical energy. Around the same time, ancient concrete began to be utilized, primarily by the Romans. This substance was a miracle material that allowed for the construction of large domed edifices without the use of columns. Modern chemists are still trying to figure out how the Romans made this material. The printing press, which was first utilized in China around 850 CE, allows for the mass production of uniform printed material, thus reducing the cost of dispersing information. Johannes Gutenberg, however, usually gets the credit because it was his machine, which he perfected in 1450 CE, that was responsible for the dramatic increase in literacy across Europe, and which ultimately led to the information age known as the Renaissance. The heavy plough was far more productive than the light plough used in Italy by the Romans, which was totally inadequate for turning wet clay in the more northern parts of Europe. The soil in northern Europe was wetter, thicker, and heavier than that in Italy, and the heavy plough made a deeper cut. This innovation was responsible for an agricultural revolution in medieval Europe, which previously had been constantly teetering on the brink of starvation. The steam engine, originally invented in 1698 CE, has innumerable industrial applications by converting water and fire into mechanical energy. Although first used to draw water from flooded mines, James Watt's modification in 1781 permitted a wider application and was used to power grain mills, making them more productive, factories, allowing them to become more capital-intensive, trains, which was responsible for increasing trade and communications across the United States, the transition from sailing to mechanically powered ships, and numerous other mechanical operations. Even the first cars. The steam locomotive was perhaps the most important application of Watt's version of the steam engine. The railroad, which began to proliferate around 1850, widens markets, increases the demand for industrially produced goods and services, shrinks transportation time and costs, and is most responsible for the Industrial Revolution in the United States. The electric battery, which has had many modifications, began to be widely implemented around 1800. It makes the economy more productive because it widens the availability of electric power. The telegraph, invented in 1835 by Samuel Morse, increased the speed of communications. Previously, the fastest form in communication was by horseback. The process of smelting metals has been conspicuously absent from this list so far. Obviously, the discovery and use of metals, first gold and silver, then copper and tin, then bronze and iron, have been important in the production process and the development of societies, both economic and otherwise. However, the most important invention was that of converting iron into steel, which is lighter, stronger and less brittle than iron. Modern cities would not be possible if society had to rely on stone, bronze, or iron. The process of turning iron into steel was first invented about 400 BCE. But it was the Bessemer process, first introduced in 1856, that permitted the mass production of steel and made its use widely available. The electric light bulb was used in England long before Thomas Edison patented, and then began commercializing the incandescent light bulb in 1879. The electric light bulb increases the amount of time in a day in which factories can be productive. The Wright brothers made the first successful flight of an airplane in 1903. Ultimately, the airplane had a similar effect on the economy as did the railroad, but on a larger, more dramatic scale. The transistor has revolutionized the world of electronics. Invented in 1947, the transistor replaced the vacuum tube to boost electrical current, thus permitting miniaturization. Space travel, modern TVs and radios and personal computers, for example, would not be possible without the transistor. On December 1, 1913, Henry Ford installed the first moving assembly line for the mass production of an entire automobile. His innovation reduced the time it took to build a car from more than 12 hours to 1 hour and 33 minutes. This decreased the cost of production, increased the supply, lowered the price of the automobile, and put it within the price range of the average American. The assembly line has been adopted in all industries that benefit from mass production and economies of scale. It was primarily responsible for putting America on wheels. The Internet was made available to the public in January of 1993. Prior to that, it was developed through a long series of innovations over many years, mostly by government scientists. The industrial applications of the Internet are simply too numerous to mention. Without the Internet, you would not be watching this video. In fact, this video wouldn't even exist. Although today we just call them personal computers, the term micro was used to distinguish it from the typical computer used for industrial purposes prior to 1970. Those computers were huge machines, often requiring special rooms, or even buildings to accommodate their use. Only specialized personnel, trained in the use of specific types of computers, could operate them. They were slow by today's standards, and not nearly as useful. The microcomputer makes computers a standard office work tool, and makes the Internet more widely available. Let's now consider the effects of technological progress on industrial concentration. Industrial concentration refers to the degree to which the majority of output of a particular industry is concentrated among a few firms. The two most widely used methods for measuring the degree of industrial concentration are the four-firm concentration ratio and a measure called the Herfindahl index. The four-firm concentration ratio is computed by dividing the output produced by the four largest firms in the industry by total output in the industry. An industry with many sellers, such as a purely competitive or monopolistically competitive industry, would have a very low ratio, as the top four firms would produce an insignificant amount of the total industry's output. An industry with four or fewer sellers would have a ratio of 1 or 100%, the highest possible concentration ratio. The Herfindahl index is the sum of the squared market shares of all the firms in the industry. The S's in this formula stands for market share. The N in the last expression stands for some number. The fact that these percentages are squared gives greater weight to the firms with a greater market share. Like the four-firm concentration ratio, the more concentrated the industry, the higher will be the Herfindahl index. For a pure monopoly, the Herfindahl index would be 100 squared, which is 10,000. What you will see is that technological innovation tends to make the production process more capital-intensive. A greater degree of capital intensity results in the firm becoming an economy of scale at a higher level of output. That means, a larger firm. An industry populated by large firms results in more industrial concentration. Technological innovation tends to result in the replacement of labor with capital. Because labor is, to a large extent, a variable cost. Therefore, the variable cost for a labor-intensive firm usually outweighs fixed costs. When a firm becomes more capital-intensive, fixed costs become more important. A highly capital-intensive firm will have its fixed costs outweigh its variable costs. Recall, from the videos on production costs, that the fixed cost curve is a horizontal line, but the average fixed cost curve continually falls and approaches the zero axis asymptotically. That simply means that it gets closer and closer but never actually touches it. So, how do you get your fixed costs down? By producing a lot of units. Therefore, capital-intensive firms tend to be large. In the year 1900, although it's hard to believe, there were over 1,900 automobile manufacturing firms in the U.S. Let this section with all the dots represent the early days of the automobile industry. Each dot represents an automobile manufacturing firm. In those early days, each car was built individually, by a team of workers. However, when moving assembly line technology came along, first introduced by Henry Ford in 1913, as we saw earlier, firms became more efficient and their marginal costs went down. Some firms invested in the technology. Others did not, either because they thought it would not contribute to their productivity, or they were unwilling or unable to pay for the machinery and equipment. Those that did invest were able to charge a lower price and still maintain an acceptable level of profit. Those that did not invest needed to charge the previous, higher price. Those that continued to charge the higher price saw their potential customers captured by those that charged a lower price. Those firms grew larger. Those that did not invest went out of business. So the next phase of this industrial development looks like this section with larger but fewer firms. During the 1940s, all automobile manufacturers converted to wartime production. After the war was over, the industry became even more concentrated with mergers and bankruptcies. Other former automobile firms transformed into firms producing other products. The firms that remained in the industry had a larger customer base to serve. So, again, in the next phase of development of the industry, it becomes populated by fewer but larger firms. During the next phase of development, the automobile industry underwent the same issues with technological progress, especially with the introduction of industrial robots. Some firms invested, others did not, and we see the anticipated results. However, the industry had to deal with some additional issues that lowered their profit margins. Foreign countries began to produce higher quality automobiles that challenged the dominance of American firms. In addition, the high and rising cost of petroleum pushed gas prices through the roof. Both of these phenomena caused the demand for automobiles to go down, as did their price and the quantity of cars sold. The larger firms were able to survive. The smaller firms were not. The industry becomes increasingly concentrated. Today, even though there are over 30 brands of automobiles being sold in the United States, there are only 3 remaining domestic automobile manufacturers whose name we recognize from the old days: Ford, General Motors, and Chrysler. However, Chrysler has been absorbed into an even larger company, Fiat Chrysler Automobiles, sometimes just called FCA. But, the industry is continuing to morph and becoming harder and harder to define. Electric cars and autonomous, self-driving vehicles are changing the shape of the industry. In another 20 years, the automobile industry will become unrecognizable from today's framework. But there is one thing for sure: the automobile firms of the future will be huge, very capital and technology intensive, and, after the industry spends some time working out the bugs, will be populated by a relatively few, very large firms. Now that we see how technological progress and innovation can affect the structure of an industry, tending to make it more oligopolistic over time, let's see which market structure is likely to produce the greatest technological changes. Purely competitive firms, recall, earn zero economic profits in equilibrium. Although a purely competitive firm would love to get its marginal costs down, it simply does not have the wherewithal to invest in new technologies. Monopolistically competitive firms also earn zero economic profits in equilibrium, but they may want to borrow in order to innovate, which could help them differentiate their product from that of their competitors. There are significant barriers to entry into an oligopolistic industry. Therefore, economic profits will not be computed away. As a result, the economic profits being earned by oligopolistic firms can be used to finance technological change and innovation. The pure monopolist, were one to actually exist, does not need to innovate because it does not face any actual or potential competition. Why would the firm take a risk by investing in new technologies when it is already maximizing its profits? It appears, therefore, that the monopolistically competitive and the oligopolistic market structures are the two most likely to invest in technological innovation. Happily, these are the two most realistic market structures. What we have seen is that the inexorable march of technological progress will, over time, destroy the competitive characteristic nature of an industry, in an organic and legitimate way. When competition is lessened, the leverage of market power shifts from the consumer to the firm. But there are less natural and organic ways by which firms can invest time, energy, and money to lessen competition. Therefore, the next video will deal with what we as a society do in order to maintain competition with markets. We must walk a fine line so as not to dissuade or dampen technological progress, which, as we have seen, tends to diminish competition. But, we do not have to walk that fine line when competitive forces within the industry are diminished by the conscious attempts by firms within the industry to do so. A body of antitrust legislation has developed since the late 1800s to deal with the forces, both legitimate and otherwise, that reduce the competitive nature of industries. The term antitrust can be interpreted as anti-monopoly. We will examine the laws that maintain competition within an industry and examples of how they've been applied.